Welcome to this technical walkthrough. Um, Thank you for joining us today for this session of Fluid Protocol IOP. We are thrilled to have Diyahir from the Fluid Protocol team co-hosting this session. Diyahir will guide us through the key functionalities of their code base and share valuable insights into their smart contracts assets. From the Immunefi side, I'm Daniel, and I'll be co-hosting this event alongside Fluid Protocol technical expert Diyahir. With that, I'll hand it over to you, Diyahir, to dive into the technical side.
Yeah, no, thanks for hosting this with me. I'm really excited to share what we have and excited for the event that you guys are putting on to, do a bug bounty for this protocol. So yeah, really appreciate everything you guys do. And yeah, so I guess we'll just dive right into the code base. And I guess at the first place people should start just to get everything up and running would be the make file. And then just to make sure everything is up and running properly, there's a couple dependencies you're going to need related to fuel and sway, and of course Rust, since a lot of the testing is in Rust. So just to make sure that you have the code base up and running properly, you should be able to just run make, build, and test. And what this is going to do is it's going to compile all of the contracts and run all the sway tests, all the Rust tests, and everything like that. And it can take a little bit to compile everything, but if you have this successfully passing, you're on the right track. So I'll just cancel this really quickly. So I guess we'll walk through the code base. So the smart contracts are in this contracts file folder, and we have quite a few smart contracts related to the protocol. So we have, we have the active pool. I guess just to step back a little bit, the fluid protocol is a liquidity implementation. Liquidity being the stablecoin protocol on ETH mainnet. So this is an implementation of that protocol within in Sway. And there's like a couple key differences between this implementation and the original liquidity protocol. One of the key ones being the multi-collateral asset support, basically. So Daniel, do you think it's best to go through the contracts, or what do you think is the most logical way of going through the code base, you think?
Yes. Whatever is the more logical way, whether this could surface as a high-level explanations, definitely we can go through contracts. So.
Okay, yeah. So we have quite a few contracts. Here we have the active pool contract, borrow operations contract. This is where the users, this is their touch point for interfacing with the protocol. And this is where the users will take out actions to their debt position. So they have you can open the trove, add more collateral to your trove, withdraw collateral, and make any adjustments you have, take out more debt, and do any adjustments you would like to your debt position. So all of this is the main touch point that users will use, and this kind of basically routes everything to the proper contracts. on the protocol side. And so then we have the collateral surplus contract. And so a lot of these pool contracts are related to handling assets as they move into different states in the system. So the active pool contract is where basically all active positions, the assets for active positions are held. There's the collateral surplus contract. This is where assets that if there's a liquidation and if there's a liquidation and you have excess collateral that's going to be returned to the user, this is where those assets are held here. There's the default pool as well. And this is where, yeah, it's a bit complicated, but this is when a trove has a pending asset and debt, and it's moved here into the active pool. We have some contracts related to staking. So the FPT staking, this is accrues rewards and in like a pro rata fashion. The FPT token contract, this is just a standard FRC20 contract, which is the ERC20 basically standard for fuel. The hint helper, this is not a super relevant contract. This is just for querying the system. These mocks are also just, just for testing purposes. Here we have an Oracle contract, which basically handles putting the price feeds in their proper format so that it can be used in the system. So it's basically like an Oracle adapter contract where you can configure it to use both Pyth and Redstone. And yeah, so this will, similar to Liquidity, have a priority and then switch based on the priority based on staleness and confidence. And that's handled in this contract. And every asset that's added to the system, they instantiate a new Oracle contract to handle that priority and stuff. Here we have the protocol manager contract. This one is related to basically registering new assets, also redeeming collateral. So this is when you have USDF to maintain the peg, basically you can redeem collateral from basically the least collateralized troves. So when you redeem collateral, it goes through the system and then finds the least collateral troves and then returns that asset to whoever is trying to redeem USDF. Yeah. So that happens through here. We have a proxy contract. So right now, everything is proxy upgradable. So we have, this is a standard proxy contract from Sway or from the fuel team. Yeah. We have the sorted troves being basically to effectively query the system. We sort all of the everyone's debt positions based on their basically collateral ratio, and that way you can effectively liquidate and redeem troves without incurring too much gas. So this handles this. And here, this contract, handles like it's multi-asset. So it's, sorting everything based on, their asset and their collateral ratio. The stability pool. You see right over here. This is basically for liquidations, users deposit USDF, and then if there's a liquidation, the person who basically fulfills the liquidation, so repays the debt, is the stability pool. And the stability pool in for taking on that liquidation, it gets to buy the collateral at a discount. So that's why that's how the stability pool works, and all of the rewards from that liquidation are distributed pro rata to the depositors. Okay, we have a couple test contracts that just help for testing. This token contract is just a standard FRC20, also for testing. And the Trove Manager, this is what basically handles all the proper, so from the borrow operations contract, that is routed to this Trove Manager contract, which handles all of the internal logic for opening troves and basically handling liquidations and redemptions and all of that internal stuff. So each asset gets its own Trove Manager contract instantiated, and so it's one Trove Manager contract per asset registered in the system. So here's the liquidations. We have the USDF contract. This is just a standard ERC20, basically, that represents that debt that people have taken out. And then the last contract that we have here is a vesting contract. So this is for, for vesting tokens. Very standard. There's a cliff, and after the cliff, things are, here we can see this here. So there's a cliff, and then there's like a total amount, and the tokens are linearly unlocked based on this. So that's a high level of all the contracts. And then in terms of like testing and stuff like that, we have here we have the, I guess before that. So these are all the contract logic right over here. And then in the libraries, this is what is basically all of the interfaces and some of the internal data structures that are shared amongst different contracts. So basically all of the interfaces are here. We have a few math related functions that we wrote out. Just to help. And here you can see this is an example of a basically a sway test. Okay, so this is all the libraries, all the shared components between the contracts. And here, so I was just about to talk about testing. So how did we test the contracts? We have basically this testing utils contract that, or sorry, subdirectory that handles all of the, just utilities for helping us test the contracts. So the tests are largely written in Rust. Here there are some, I guess, regression tests in Sway, but primarily, here I can open an example. Primarily, the tests are written in Rust. So here in the test utils, we have basically the ABI interfaces that help you interface between Rust and the Fuel VM. And using this, we can do basically Rust regression tests. So here we have all the ABIs that we would need. And then we also have basically a setup function. So I guess I can go back to this test here and just show you a standard test that we have. So, there were a lot of contracts that we just went over, and getting the system set up properly takes a bit of work. So we handle that basically at the beginning of each test with the setup protocol function. And then this will basically, if your test, has like 2 assets, then, you have a test or you have a flag for that. If you're testing things related to the token, because there's like a time component to that, there's a flag to deploy a mock token here. And the setup protocol basically it deploys all of the core contracts. So all of these contracts that we just went over, it'll deploy them here. You can see what this looks like. And then once you deploy them, and this is all happening locally on like with their tooling that they wrote out, which is really cool. And then you initialize all the contracts. So basically just set up everything properly. And then over here. And then, so once you basically deploy all the contracts and then initialize them, you're ready to register an asset so that you can take out debt and get the system going. So you have this add asset, which goes through some of the stuff that we had talked about. It deploys a mock Pith oracle, a mock Redstone oracle, and then the adapter oracle that we use. And then it has the Trove manager, which is unique to each collateral, as well as just like some other logic related to getting the asset added to the system. Here we register the asset as well. So once you have all of this set up, let's go back to the test that we were looking at. Once you have the test, this protocol set up, you have the number of assets that you wanted to add, then you're ready to basically start writing the test that you would want. So this is an example of a test, and obviously you can run it here. So if you did find a bug, this would be should be pretty straightforward to demonstrate it using a script like this. And every contract has a basically some tests that we wrote for basically end-to-end tests. So here we have some as well for the active pool. We test events, expected failures, pausing the protocol. And every contract has a bunch of tests that we wrote out. What else here? Here we have so that was all related to the end-to-end tests that we have, as well as the regression tests. But we also have basically some deploy scripts. And these deploy scripts are related to basically launching the protocol on testnet and on mainnet. So, which you can do using the make file. Just run this command and set these parameters. So here we have. So yeah, we have the deploy. Deploys the all the contracts. It's the same as the regression test or that setup protocol function that we just went over. That is how it sets it up, just using testnet or mainnet. And then here we have, I guess, some setup parameters for using the real testnet and mainnet IDs and parameters for each asset. So these are some of the supported collateral types that we have. So that when you register the asset, it, registers the proper asset. And there's some sanity checks as well here. So, yep. I guess, yeah. Daniel, what do you think? Is there something that I missed here that you think I should go over?
No, I think you've gone through each contract, so we're pretty much good on this hand. So if you're okay, we can go through the questions that I.
Oh, right.
Okay, so the first questions I have is what are the most important bugs you have received in previous audits that you haven't expected to see, and how did that challenge the security assumptions or threat modeling of your system?
Yeah, so I guess the biggest bug we saw was related to the Trove manager, which basically the system relies very heavily on the sorted troves or all of the debt positions being sorted properly and to never have like a missorting of the troves. This is important for basically there's some actions that are restricted if there's a trove that can be liquidated, right? And there's other actions that, such as the redemption of USDF into the collateral asset, that require or that relies on these troves being sorted properly so that the person who's being redeemed against has the least collateral ratio. So they have the most risk in the system, right? So we had one interesting bug related to basically a missorting through like some various actions that could result in a missorting. And yeah, if the troves get missorted, then people who are being redeemed against, it could be the wrong person, or there's situations where some restricted actions should not be happening. But if there's a missorting and a trove should be or is in the liquidation can be liquidated, but there is a missorting, then some actions that should be restricted are not restricted. So I think that's one of the interesting bugs that we found was through like a couple of actions you can missort the troves.
Okay. The next question is going back around the topic that you described around the first question. What are the most important areas you feel people should focus on looking for bags or?
Yeah, I think I think any area where you can potentially missort the troves, just going back to that bug that we just described, situations where you can missort the troves, I think, are really important for the system to function properly. And then secondly, there's, I guess, something related to precision. In the fuel VM, basically, they're using U64s, 64-bit integers, whereas on ETH mainnet, it's 256 typically. So there's some potential for precision losses or for errors to accumulate a bit more quickly. So I think an important part that people should look out for is basically error accumulations that are downstream of basically 64-bit integers. So I think those are probably the two places where I would focus on.
Okay, in fact, the third question is in more related to specific tips you and your team would share with a security researcher about what to look for in your code base.
Yeah, I mean, tips, I think there's there's the Liquidity implementation, and obviously we have some differences between the Liquidity implementation, but Liquidity it has stood the test of time in terms of resilience and security. So I think there's with differences, there's potential for bugs and stuff like that. So I think where there's and we try to keep the implementation very close to Liquidity. So I think where there's deviation, that's probably a place to just be like, oh, okay, this is interesting. Let me dig deeper into this change and make sure that it still makes sense and doesn't basically result in some unintended behavior.
Mm-hmm. Right. And on top of these tips, what resources would you recommend for learning more about your project and code base?
Yeah, so we have basically some documentation, high-level documentation on the protocol. We also have in every contract a description of what it does, as well as we have an audit report by AutoSec that could be a useful place just to see what types of bugs have been found previously. And then I think the Liquidity code base is pretty valuable because they have, I guess, the same or a very similar implementation, as well as a couple of basically research articles related to some of the math used specifically in the system. So yeah, I think those would probably be the best resources. So obviously, yeah, the documentation, the code base, and then the Liquidity resources, I think would be the most valuable.
Perfect, thanks. And can you explain the various access control roles within your protocol, if any?
Yeah, so I guess there's actually quite a bit of access control within the protocol. So here, let's just open an example. Basically, almost every contract has access control related to it. So for example, here, basically, so the active pool, right? The active pool is where the asset lives, or the collateral lives for troves that are basically active debt positions. And here you can see there's access control related to make sure that the caller is either the borrower operations, the trove manager, the stability pool, or protocol manager. And you can see there's like different types of access control based on what function is being called here. And this is basically true for every contract. Every contract has some access control for basically interfacing in the system, just because there's it's kind of a big system. So yeah. And then here, I guess there's access. There's probably 2 or 3 different, I guess, categories of access control in the system. Here we have, I guess, this internal routing access control, like here, where you're just making sure that the contract is basically has access to that function, right? There's a second access control, which is basically related to basically like authorized users or authorized like multisigs. And this would be something like a pauser. So here in borrow operations, there's basically an identity that can pause or unpause the system. And when the protocol is paused, basically you can't increase the debt in the troves, but you can still unwind a position. So if you want to pay off debt while the system is paused, you can still do so and unravel the position. So that's one. There's another, I guess, a bigger, more security critical access control in the protocol manager contract. Basically, I mean, these all implement the owner standard, SRC3, or is it 3 or 5? Yeah, SRC5. So they all implement that, which lets an owner do specific actions. Here, I guess a critical action that's taken is the register asset action. So this lets you register a new collateral type to the system, and it basically registers it to all the contracts. So this is, I guess, one of the more critical actions. And then, right, there's another. So yeah, so that's the second type of access control, and then the third one is related to the proxy upgradability. So all of the contracts, at least in the beginning, will be proxy upgradable. And then as the system hardens, the plan is to basically renounce the ownership of these, renounce the ownership of the contracts and let them just be non-upgradable and immutable. So that would be the third access control. And here, if we actually go to the testing utils, we can see how it's set up actually. So here, if we go to deploy, so what we have here, let's say we're deploying the borrow operations contract. Yeah, so what happens in the background is we actually deploy a proxy contract, and then yeah, just do this just, standard proxy upgradable code pattern. You use the proxy as the contract ID, and then here we have an implementation so that if we do need to upgrade the contract, we can do so. So yeah, so those are the 3 different access controls within the protocol. We have, the internal routing between all the contracts, and each of the critical functions have their that access restricted. We have the, I guess, the special roles within a few of the contracts to register assets, to pause the protocol. And then the third is the proxy upgradability. So yeah, I think those are like the 3 branches that we have.
Sounds good. And the last question is, which areas of your code base do you anticipate will be the most challenging for our security researchers, and where do you expect bugs to arise due to implementation complexity?
Yeah, no, that's a good question. I think the most challenging place will be the Trove Manager contract, because I guess there's a lot of logic here that, and yeah, there's a lot of logic here, a lot of moving pieces. And this is basically handles the, most of the logic within the system and handles doing everything properly. So I would expect if that the bugs would be in this contract, and I think less so in the other contracts, because it's mostly just mostly just access control and routing into this Trove Manager contract, which handles basically liquidations, redemptions, registering new troves, adjusting trove, collateral and debt. So this contract has I think the lion's share of the logic and complexity. So I would probably focus on a contract or stuff here, because I think this is where you'd probably have the highest chance of finding bugs.
Awesome. I think we covered both in high level in detail many information regarding your protocol, and we do thank you so much, Diyahir, for these explanations and for the many intricate details you provided. Truly awesome. Just as a quick reminder, Fluid Protocol is running an invite-only program. It's a server audit competition on Immunefi with 80K reward pool up for your grabs. And for more details about the competition, visit immunefi.com/explore and check out the Fluid Protocol program. Also, if you have any follow-up questions, feel free to reach out Fluid Protocol team on Discord, and the technical team will be happy to provide further clarification through the designated Discord channel. Once again, thank you all and happy hunting.